All right, we are to the second half of lesson 7.4. We have a few more theorems about some special parallelograms. So the first one here is the rhombus diagonals theorem. It is a rhombus if and only if the diagonals are perpendicular. So in a rhombus, the diagonals will always intersect each other at a right angle or a 90-degree angle. Now this other one is a little bit unique. A parallelogram is a rhombus if and only if each diagonal bisects the other angle. So let's say angle B was 60 degrees. That means when I draw on the diagonals, it splits it perfectly in half to 30 and 30. Now I'm going to guess some of you try to do that on your other parallelogram homework, but this only works if it is a rhombus. It doesn't work for every parallelogram, just for a rhombus. So let's apply those two theorems that we just learned. Here we have a rhombus. Now what do we know about a rhombus? We know that the diagonals intersect each other at a right angle. So therefore, angle 1 is equal to 90 degrees. Now we got a little bit of work to do. We have to unfold and figure out what the rest of them are. Well, if this angle here is 61, that means angle 3 is also 61, and angle 2 is also 61. All right, so those are both 61. Now, how do we figure out angle 4? Two different ways. I like to look at it and break it down as a small triangle. Since angle 1 is 90, angle 3 is 61, I'm going to go ahead and add those two together. And I get 151 degrees. Well, a triangle has to add up to 180, so 180 minus 151 would make angle 4 29 degrees. That's one way of thinking about it. Now, you could also think about it as a whole parallelogram. We know that these two are both 61. So 61 and 61 makes this whole angle 122 degrees. Well, what do we know about parallelograms? They have to add up to 180, the consecutive angles, which would make angle D, the whole entire thing, angle ADC, 58 degrees. But I don't want the whole thing, I need to split it in half. So then splitting it in half would give me 29 degrees. Just another way to think about it. Now in this different way of thinking about number 6, I actually answered the second part of it. What is the measure of angle ADC? Well, it's 58 degrees, that'd be the whole thing. What's the measure of angle BCD? Well, if this is 122, BCD, or double 61, would also be 122 degrees. So either way that you would like to think about it. All right, go ahead, pause the video. I want you to figure out what the angles are in the next diagram. All right, so actually all four angles in this diagram would be 31 degrees. And two ways that you can think about it. Again, you could break it down into the triangle. Subtract off the 118, you're left with 62 degrees. 62 has to be split evenly between angle 1 and angle 3. One way to think about it. The other way to think about it is consecutive angles have to add up to 180. So 180 minus 118 is 62. 62 divided evenly between those two makes each one 31. If those are 31, then angle 3 and 4 are also 31. So they are all for 31 degrees. All right, we've got one more theorem for today, and it's about rectangles. Rectangles, diagonals, yes, they bisect each other. They cut each other in half, but, because they're a parallelogram, but they are also congruent to one another. This is unique only to rectangles. Not any old parallelogram, just for the rectangles. So let's take a look here. We got a window we're installing in a building. Now the opening has to be a rectangle. Given the measurements in the diagram, can we assume it is? What do you think? We know the opposite sides are congruent. That's great. It's a parallelogram. But we do not know what the angles are. We don't know that those are right angles, so we cannot assume that. No assuming. However, let's take a look at B. It says the diagonals of the open are 54 and 8/10 and 55 and 3/10. Well, if the diagonals are not congruent, is it a rectangle? Nope. It's a parallelogram, sure, but it's not a rectangle. If it were a rectangle, those two diagonals would be congruent to one another. All right, a little bit of algebra for you, so go ahead, pause this video and solve this problem. All right, hopefully you picked up that QS and RT are the diagonals. Well, if it is a rectangle like it says it is, the diagonals have to be equal to one another. So I went and set their values equal to each other, solved for x, and the value of x is 14. Now, that's not all they asked for. They said find the lengths of the diagonals. So we got to substitute that 14 back in. I'm going to pick the 2x plus 11. Mental math for me. 2 times 14 is 28, plus 11 is 39. Now, if this diagonal, RT is 39, then we can assume QS is. But if you wanted to double check your algebra, you would plug it in for QS, and when you do, you also get 39. So QS equals RT, and it's equal to 39. All right, let's go ahead and graph these 4 points, and then we have to decide what shape it is. Now, we can see here, yes, we have a parallelogram, that's given, but to determine whether it's a rectangle, rhombus, or a square, we have to decide what we know about them. Now, I think this one's pretty obvious. We can tell that they're not 90-degree angles, but to just verify. So all of the side lengths are the same in this shape. Now, we could do that by calculating the distance formula for all of them, but we can also see that they all have some, use a different color here, some ratio of 2 and 8, or 8 and 2. Some ratio of that, so all 4 side lengths are the same. So it is for sure a rhombus. Now we have to decide if it's a square or a rectangle. Now what do we know about rectangles? We know that their diagonals are congruent to one another. And you might be able to just look and say, yeah, I know that they're not congruent to one another. The one looks shorter than the other one. But to actually prove it, to find the length of AC, if we use the distance formula and simplify, because we love to simplify radicals, it is 6 square root of 2, which I got from simplifying square root of 72. I won't be too mean, but you still need to know how to do that. Okay, the length of BD is equal to 10 square root of 2, or the square root of 200, but I just simplified it. All right, so we can see that those two diagonals are not equal to each other. Now, again, technically to do this, we would find the side lengths of all of the sides and show that, yes, they're all 2 square root of 17, every single one of them. But like I said, I just used the ratio of those slopes and saw that they were the same. So the sides are equal, but they are not congruent diagonals. Therefore, that rules out a rectangle, and it's not a square. And we can also see that the slopes of these diagonals are opposite reciprocals of one another. So the slope of BD is going up 1 to the right 1. AC is going down 1, right 1. So they're opposite reciprocals, which just reinforces that those cross at a 90-degree angle, which is why it is a rhombus as well. All right, you've got this last one. Prove what shape it is. So go ahead, graph it, and then decide. All right, hopefully you got it. It is all 3 of those shapes. It's a rectangle, it's a rhombus, and it is a square. All 4 side lengths are congruent. If you check the diagonals, the 2 diagonals are congruent, or in this case, if you check the slopes of the sides that are next to each other, you'll see that they are opposite reciprocals. So I went ahead and sketched that in so you can see exactly what I'm talking about. So 2/5 and 2/5, -5/2, -5/2. Clearly they're parallel. And they have the same ratio, so they are the same side length. But you could find the side length if you wanted to. Now, because if I look at these 2 sides, I want to know if they're 90-degree angles. Well, what do we know about the slopes of perpendicular lines? They are opposite reciprocals. So we got a positive 2/5 and a -5/2. So a positive and a negative, opposite, reciprocal. We're switching around the numerator and the denominator, so 2/5 to 5/2. Yes, indeed they are, which forces those to be 90-degree angles. So all 3, rectangle, rhombus, and square. All right, that's a wrap for lesson 7.4. You are now good to go ahead and do the homework.